Hello, hello, hello. Welcome to LaserBeam Live. This is episode number 47. You know the deal. Whether it's morning, afternoon, evening, or night, I appreciate you spending just a little bit of your time with me. And if you're watching this back, thank you too. My name is Ikenna Ofoha for CNC Labs. And yeah, what are we doing today? We're actually going to be talking about the roadmap of the LaserBeam product line. We're also going to be engraving, or actually, no, we're going to be cutting and engraving some quarter-inch plywood. So, you know, we're going to be trying to get even better results. I think we're taking what we learned, all our different live streams where we're doing a bunch of cutting with the 3mm and the quarter-inch ply. I think we're going to take a lot of what we learned and try to implement it with a 3-element lens, cutting the quarter-inch ply today. But let's check out the chat. Dana is in the chat early. He might not be joining us for the whole stream, but he came in to say hello. We appreciate you, Dana. Nicholas J, thank you so much for joining us. You're always in the chat. Steve B, Steve Berger, thanks so much for joining us. Desmond Lung is asking, what is the approximate dimensions and weight of the Ultra Beam? I cannot give you that, but the work area will be about a 24-inch by 24 inch by 36 inch. So 3 feet by 2 feet is going to be the work area. It's because this is a CO2 laser, it's probably going to end up being around probably a little over 100 pounds. But I cannot give you an accurate kind of weight until we actually finish the thing. But you can take a look at the size of roughly the 12 by 30 long mill is going to be roughly the same weight. I have the 12 by 30 sitting right here, and when I enclosed it and I compared measurements of my current design of the UltraBeam CO2 laser, it is roughly a little bit shorter than my enclosure, which is housing a 12 by 30 long mill. So I think a 12 by 30 long mill is going to be a good kind of gauge of how big this laser is going to be, and then maybe add a few inches on each side for the actual final width, because you're going to have the enclosure around the actual CNC mechanics and optics of the actual CO2 laser. So Desmond, hopefully that gives you a pretty good answer. I would say it's going to be probably around 30 inches by 40 something, 42, 45, let's say 42 inches by about 32 inches overall. And it's going to be it's probably going to be above 100 pounds. It's probably going to come in 3 easy to assemble boxes, something along those lines, very similar to our alt mill. Daniel, lead engineer for alt mill, Patrick, our head of operations, and Jason, our lead customer service / marketing manager. He's kind of been, all 3 of them have been pushing really hard to get to the launch of the alt mill. So we have our pre-orders in, the first 50, and our whole QA team, all our QA engineers are working very hard to start the assembly. They've already started the assembly. Our packers are slowly starting to assemble the first 50. Yeah, Desmond, you won't be able to hand carry it around the house, unfortunately. That's one thing you won't be able to do. But, you know, you can set it up on a table with legs and some wheels, so it's easy to move around. But yeah, like I was saying, alt mill, the whole team has been working very hard to get the first 50 out. Everything's coming together. The resources are getting put together right now. They're making a lot of headway with that. The boxes came in. The branding looks amazing. It looks really nice. Yeah, everybody's just pushing really hard to get the alt mill, the first 50 out the door, and then after that, the first 150. So very excited for that. The company's pulling together. I think we just released a production update, so if you want more granular updates on the production and everything else, go check out that video on our YouTube channel. Awesome. Other than that, UltraBeam update. So guys, I'm currently designing the UltraBeam prototype version 2. Version 2, you know, I was sleeping last night. Michael Levine, thank you so much for joining. Thanks for saying hi in the chat. Okay, so let me take you through the story. So about a week ago, I would say last Wednesday, I woke up and I had a vision. I had a vision of exactly what I wanted the CO2 laser, the UltraBeam CO2 laser, to look like. And for the past 8-9 days, I've been fervorously designing and sourcing and reaching out to manufacturers and part suppliers and everything, because I feel like I have the vision of what this thing needs to look like in its production model form. And you know, after taking in a lot of what you guys wanted over the past little bit, I finally had to just come to the term, like, I just need to make something right now that I would like because I love CO2 lasers. I love lasers. I've listened to all of you guys about what you guys would want out of a CO2 laser. I've been in the forums, I've been in the Reddits, I've been everywhere. And what I need is now I've consumed that information. Now I just need to design and make something that I would be happy with to have right here and I would enjoy using. So with that in mind, I've been able to accelerate the design myself and just continue to design and push forward. And my goal is to be having a pre-production model probably early July. And then the goal is to replicate that pre-production model so we have a couple extras so that I can be testing internally, and then we can also start the preliminary testing with the agency. So we'll start with the consulting of the safety agencies. So yeah, the product design gods woke me up a week ago and gave me the vision of what this CO2 laser, the ultra beam laser, needs to look like, what I want it to look like, and I'm very excited. And I've been working very hard, so I'll have a new pre-production prototype ready to go probably in the next month. And then hopefully you guys will see the vision, you guys will see what the final form factor will look like. I can give you guys better specifications in terms of like dimensions and all that, and then we can go from there. We can start talking to the safety companies, start working out the tests that need to be done, and then we'll open things up for pre-order. So I'm pushing things along as well, but I also finally finalized a plan for where I want the LaserBeam to go forward. So the LaserBeam is like my baby, okay? It's like my firstborn child. Of course, it was very stressful. I worked very hard. I also learned a lot, and there's some things that I would implement now that I didn't implement back in the day. And rather than trying to move on and forget it, I would like to continue to iterate on it. So this is my current plan of hashing things out of how I want the LaserBeam product dev to go. So phase one is going to be the magnetic mount, which I actually have mounted on my laser. So I'll show you guys in a second. I have the magnetic mount. I'm going to optimize some of the hardware and stuff, order the supply chain for a couple hundred for a first batch, and then get that on the website for you guys. Next is going to be a honeycomb bed, because over the past couple months we've been doing a lot of cutting projects, and we've all learned that raising your material off the bed gives you way better cutting output. So why not just find a supplier for some honeycomb beds? It's not rocket science. Put some CNC branding on it and let you guys use it. So I actually bought one on Amazon just so I can test it out and make sure that I like it and I like using it. Then I'll probably just order same thing. I'll order about 100 or 200 from our supplier overseas, and yeah, so you guys can buy it. Because honestly, we're just trying to raise the quality of what you can do with the LaserBeam. So first things first, magnetic mount, easy slap on, slap off for when you're using the router. We have the offsets and G-sender, so it's easy, switch over from router to laser. Number two is the honeycomb bed, because it's very simple. I'm doing testing on very similar models right now, and yeah, you just slap it on. You have these little, these pinhole clamps, so you can clamp your material and everything. That's number two. Then it's going to be a Pro Air Assist, so Air Assist that's going to have the tube go directly into the nozzle. Right now we have one kind of a blower type Air Assist, but now I'm going to design a Pro style Air Assist that screws onto the lens cover and that covers the beam completely, and the air flows in through a mini compressor. So we're going to sell that with a mini compressor. And then lastly, it's going to be an air vent or an air vent kit with a filter option. So essentially we're going to take the dust shoe design, we're going to add a little mouth to it so it gets closer to the laser. We're also going to add a tube adapter that you can buy as the whole thing as a kit, or if you already have the dust shoe, you can put the parts on to adapt it. And that will allow you to put a standard 4-inch hose or ducting so that you can duct it out. So we'll sell a fan, an inline fan, and then maybe we'll get into the filter we'll get a reliable 3-stage filter so that you guys can start filtering it out to go outside, or filtering it. Like right now I have a filter, I have a 2-stage filter, pre-filter and carbon filter, and it filters into my apartment, and it's been pretty good. But I'm sure if I tried to run it a lot more, I'd want a more robust filtering option. So that is phase one: magnetic mount, honeycomb bed, Pro Air Assist with a mini compressor, and the air vent. So that's phase one. Phase two is we're going to be doing an updated laser driver for more reliability. We're going to add a troubleshooting tool to every laser so that if anything does go wrong, you'll have a tool so that we can actually find out exactly what it is, and our customer service will be a lot better. I also want to work on a modular enclosure kit, because ever since I built this enclosure for myself, everybody's been asking me, how do I make an enclosure? How do I make an enclosure for your CNC or your CNC and your LaserBeam? So I will be designing a modular kit that will probably use mostly 3D printed parts plus some aluminum extrusion and some acrylic and some MDF, and then you could use whatever materials you want. We'll sell it as a kit, a flat pack kit, and then you can also obviously get the designs online. So that's going to be part of phase 2. It's going to be updated laser driver, a troubleshooting tool, and a modular enclosure kit. And then last but not least, we're going to go towards a 20-watt diode laser and a standalone diode laser CNC, right? So a small, light CNC. For those of you who don't need the CO2 laser, so the CO2 laser is probably going to come out, so it's probably going to be phase 1 of the LaserBeam parts are going to try to come out before the CO2 laser, then the CO2 laser, then phase 2 of this LaserBeam, then phase 3, which is this 20-watt diode laser, and a CNC just for your diode laser. So it's going to be light, quick, easy. It's going to run off your longboard. And yeah, so that is my 3-stage. Now the point of this is for if you don't need a CO2 laser, you love your LaserBeam, I want to add enough things to the LaserBeam line that you don't feel like you're being left behind by the rest of the industry. So magnetic mount, honeycomb bed, pro air assist, air vent with filter, better driver, better customer service, a modular enclosure kit, 20-watt diode laser option, and a standalone CNC, so that you can kind of build your own laser use, right? It's not just based off the long mill anymore. It'll be its own little line of stuff that you can kind of modulate and get what you need. But that is going to live on its own, separate from the Ultra Beam, and so that it doesn't get forgotten and left in the past, right? So that is my 3-phase plan. It might take some time, maybe 18 months, to get all 3 out along with the CO2 laser, but I'm very optimistic. Once we start releasing little things, that will help us fund the production and the development for the other things. So it'll kind of be a snowball effect. So yeah, I'm done. Okay, that's it. Let's get to making a project. Let's get to cutting some plywood. So I'm just gonna make a frame that's the size of my material. So I'm actually gonna make it half my material because I want to get two cutouts out of my current material. So right now I'm gonna do 25 by 70. Put that at 0, 0. And then, yeah, so now we want to do a cutout. So I'm gonna make another rectangle, probably just a little bit smaller than this. So I'll make it, yeah, 20 by 60. So 20 by 60. I'll just make it, I'll offset it by like 2 and 2. Now I want to use some let me change the color to cut on this so that we know it's a cut. And then I kind of want to start messing around with some of the vectors here. So I kind of want to round this. So let's round this and round this. And can we increase the radius? Let's go back and let's try a 15 radius. And what happens when we try to 15 radius? Oh, it's too large? Okay. So let's go 10 again. And let's round this edge. And let's round this edge. And then let's, what can we do here? Can we start playing around with the nodes maybe? So let's start messing around with the nodes here. I want to leave that alone, but I want to essentially add a node. Maybe there's a way to, oh, I kind of like that. Oh my God, you guys can't even see. Sorry guys, let me zoom in here. So all I did was add a 10 radius here. So I made a rectangle and then I selected my radius was 10. I selected this tool and I clicked on the corners. It smoothed this out. Then I clicked here and I started editing the nodes. So now I kind of want to add this little dip because we're making little garden tags. So you kind of want the end to be a little bit have this little bit of curvature to it so that it kind of sticks in. Yeah, and that looks pretty good. And now I'm just going to make a tag. Oh, actually, I'm going to round the top edges just because it'll look nicer. Make a small radius of 5. Add that there, add that there. And then let's add some text. So let's pick some nice font, get right here. And we'll do something easy like, whoops. So we'll do some basil. And we'll engrave that. So turn that black and then we'll rotate that 90 degrees. Yeah, so there we go. Easy peasy, so simple project. So what I want to do is engrave this, and this is 1/4 inch, right? So 1/4 inch is going to need at least, let's say, I think we can get away with 6 passes. That's what I think. And there we go. And probably let's do 4 millimeters per second. And then for the engrave, we'll do 40 millimeters per second at 80% power. So something simple. But now, what I'm really curious is how many passes is it going to take and at what speed to cut out 1/4 inch plywood, because I remember before when we raised it, we had some pretty good luck cutting out of 1/4 inch, having to drop it from like usually when we do 8 or 9 or 8 or 10 passes to I think we were getting away with like 6 passes. So I want to at least if we keep that same efficiency, or we get even better because this is a more legitimate honeycomb bed rather than like raising it with some scrap acrylic, right? So we'll export this. And we'll call this basil tag. And we will go to GSender. We're all connected to our SLB. And we're all focused. So now I kind of want to show you guys the current iteration of the magnetic mount. So I don't know if you guys can see that, but let me lower this for you guys. All right. So I think I'm going to try to raise this and kind of get you guys under here. So, as you can see, it's pretty standard. You just bolt it into the place of where your laser beam was, and you have 5 magnets because you have different orientations. You have this mount, you have the wider version 1 mount that kind of flares out further, and then you have your vortex mount that creates this like L shape, right? So like you'd mount it here, you mount it there. So you align these little studs to the hole, and then you just press up and move it out. So you unplug this, and now your laser is off your machine. So running between laser and router has never been so much, like so easy, right? You align these little studs, you let it click, right? You bolt these 2 on, you align your studs, and you remove it. So it's that easy. So I'm very excited to get this out to you guys so you guys can start ordering this. We'll get the supply chain done. We'll start 3D printing. We already have these magnets in stock, so there's not a lot of supply chain. Yeah, so again, removing your laser from your CNC and putting it back on has never been so easy with the magnetic mount. You align your studs here, and you let the magnet take over, and you're good to go, right? Very simple, very easy, a very simple solution to a very annoying problem for most of our users, and it's that easy. So now I'm going to let you guys see that. So as you can see the honeycomb bed. We're raised, we have measurement, we have these little clamps, you know, let's say I was using the Pro Air Assist and we don't want it to blow the material away, then I could use these little clamps where, you know, drops over your material and sticks in, keeps the pressure down, keeps it from moving. Usually I only have that issue when I'm using Air Assist, so definitely gonna need that. So that's definitely something we're gonna start offering. So magnetic mount, honeycomb bed, Pro Air Assist option, air vent, air filter. So that is kind of like the start. So now I'm already focused, I'm already kind of zeroed out, so I can load my file here. See if it, okay, we got, our zeroing is all good, so let's zero it all. We're all good here. I'll just double check my laser. Yep, I'm all focused to the corner. And this is actually the 3-element lens. So every time I've been cutting before, I've been using the G2 lens, right? But the G2 lens has higher efficiency, but has a bigger beam focus size, right? The 3-element has worse efficiency than the G2, the G7, or the G8, but it has the smallest beam size. Yep, Nicholas, it would work. It will work on the side mount. Yes. You should be all good on the side mount. So I'll double check the spacings. But worse, like obviously before we release the design, we'll double check it with all versions of the router mount, all sizes, all versions, and we'll make sure that that works correctly. Sorry, LED light. Yeah, so I'm very excited. It's a very simple solution to a very annoying problem. So very glad to get that out of the way and start kind of phase 1 of the next set of accessories for the LaserBeam. All right, so let's get started with this. So we'll go ahead and start this project. And I'm very excited to see how much, see what the cutting is like on this thing, especially with the honeycomb bed, with the 3-element lens. Like I'm very excited. This is definitely like one of those experiments that actually might yield the best cutting results, right? With the small beam, you can kind of even tell by how thin the wire is. Sorry, I don't know why this light. There we go. Hopefully that stays on. But yeah, you can kind of tell by how small the beam is. So So I actually won't know which pass actually cut it out. I think we're finishing up pass number 3. It actually does seem to have cut out already. So I'm curious. I kind of want to check it after this pass. So this is pass number 4. Scott. Scott needs about 3 dozen of these, okay? For his little garden. You must have an amazing garden if you need 3 dozen of these. That's actually very impressive. Scott, hit me up and we can speed up this process on the CO2 laser at the office, okay? So I'm taking a risk because if this is not actually done and I move it, it's gonna offset it and I won't be able to cut it. Michael says, is this the laser with 7-watt diode laser with the 3-element? Yes. So this is 7-watt, our standard. There's only one LaserBeam. It's 7-watt. This is with the 3-element lens. Oh, of course, landscape architect. How did I not know that? Yeah, your garden is probably immaculate. Okay. Yeah, hit me up and we'll do some on the CO2 laser for sure. I'm down for that. So yeah, regular 7-watt laser with a 3-element lens, very tiny beam. So I will have to double check you will have to remove your, yeah, you will have issues mounting it with the dust shoe. So I'll have to double check all the mountings and stuff like that to make sure that it all works. So just stay tuned. So I will be taking a risk by trying to move it, but I want to know because we have the best kind of setup here for cutting. So I kind of want to find out if we were able to cut with 4 passes, right? So 4 passes, were we able to cut through this? Okay, we weren't, but I think another added benefit of the bed is because I had it shimmied against the corner of the bed, I just put it back there. So it might still be off a little bit, but I have high hopes that I won't have to restart and that I'll still be kind of in line. So honestly, I think I am pretty much in line, but I might be a little bit off. We'll find out at the end of the. Yeah, we might be in line, we might not be. Who knows? I just wanted to know if 4 passes would be enough. It wasn't, but even 6 passes is pretty light compared to, you know, the 7, 8, 9, 10 we were using for the plywood. But again, you might have better luck with a more solid, softer wood, like a Baltic birch. You might have a lot better luck with like a solid, softer wood, rather than plywood, which might have the adhesives and stuff like that. And then of course we're not even using the air assist, so I can only imagine this plus air assist, how efficient we can get. So maybe we'll run this exact project with the air assist on, right next to it, and then we'll see the difference. This is the last pass right here. So the cut lines are so much smaller. It's really nice. Even though we're losing like efficiency, the beam size is just so small that even your cut lines, they look so much smaller. Which I really like the look of, honestly. So I'll just switch this up. switch this up to mint. We'll go ahead and save that. I think I might have to run it, because I tried to open it up after 3 passes. If it didn't cut all the way through, I kind of want to run it one more time, same everything, and just let it run without me touching it, just so I can get a direct comparison before I try to mess around with some other stuff. Does that make sense? All right. So we didn't cut all the way through, but we're pretty close with 6 passes. So you could see the end. And to be honest, I want to try one more time with 6 passes without me touching it or anything. And then if it doesn't work, we'll try 6 passes with air assist. And then if that doesn't work, we'll do 7, because I know we'll get away with 7. But guys, I'm also running it a lot faster than I normally would. Usually I run between 2 and 3 millimeters per second. Now I'm running it at 4 millimeters per second. So I'm up by like 25% realistically. So the fact that I was even able to get a score line at the back, running it 25% faster than I usually run my cuts, is pretty impressive. But I also touched the job in the middle of the, so if I even misaligned it, then it probably wasn't cutting in the same exact spot, which might have made it harder. So I'm just gonna run it again, the mint version. Just so I have a better baseline without me trying to interrupt it. So we'll start that job. And then we'll do it with air assist. If this doesn't cut out perfectly, we'll run it with air assist. Actually, regardless, we'll run it with air assist just to see, and we'll see, maybe I'll try 5 passes with air assist. And if that doesn't work, maybe I'll try 6 passes, but up the speed ever so slightly. Zeus is here. He needs some pets. I have to pay the toll, okay? We all have to pay the Zeus toll, okay? Come on. You want to join the stream? Good boy. Welcome, welcome, welcome to the stream. Oh, hey, buddy. Hope you guys enjoy it. All right. He's like, all right, I'm done with your stream. Stream is, you don't like it? No? All right. Well, you do your thing while I finish this up. So it's doing its passes. I'm not gonna touch it this time. So this is the same exact piece of wood. I just flipped it around. And it's the same job. I just changed the lettering from basil to mint. So we'll see if this cuts through in 6 passes. 4 millimeters per second. So guys, this is much faster than I usually run my cuts. So if we can get away with 6, then the honeycomb bed is definitely doing its job and making it a lot easier for us to cut, in combination maybe with the 3-element lens. So I'm gonna grab another piece of wood, because then after we're gonna run it with air assist. Sorry, this light, it's very unpredictable today. I don't know, seems like the power supply, the wires are a bit messed up. But let me grab another piece of wood. So we can, a little 1/4-inch piece of ply, so we can run some more tests. And if I find that over the next little bit, the honeycomb, which kind of already I suspect makes it really, really easy, I'm going to find a supplier for them, My goal is to try to make them modular because although you guys might not be running very large jobs, right, that will take up the entire bed of your long mill, like you might be able to get away with the one similar to what I have, which is probably like, what is it, 300 mil by 300 mil, 300 mil by 200 mil. I would like a modular one that if you buy one, you're fine, you just get it in the size. But if you want to buy, if you want to fill your whole long mill space, doesn't matter what size you have, then you could buy a certain amount of them that will like fill the space, right? So that's my goal with this, not to just like, I could find a supplier for these and order like 200 and then put them up for sale for you guys, and they would ship in like 4 weeks. But I'm gonna try to figure out a kind of a clever way that you can stack these together to fill out your entire long mill work area, no matter what size long mill you have. So if you just want one, that's 300 mil by 200 mil, but let's say you do really large jobs for laser, then you can also get a modular work bed. But I kind of already like the fact that I'm raised above my work bed, the fact that I have the measurements there, the fact that I can corner it, I can corner my piece against something, so it's a little bit easier to do repeatable jobs without having to worry about all that. The fact that I have these very easy clamping systems, and you can even laser wooden versions of these, right? So if you need more, you can always make more using your laser, which is always a cool thing. So let's see how this job did. If this didn't work, then we're trying 6 passes, same job, but with an air assist. All right, so this just finished up. Let's check on it. All right, so we definitely cut way more through, but we just didn't cut all the way through. So you can see the outline is like, it's just about there. Like it's just about there. And then you can see this one was worse, right? You can still see the outline, but this is 6 passes at 4 millimeters per second. So right now, I have the option to either lower the speed and go to 3.5 or whatever, or I'm actually just gonna slap on the air assist, and this is gonna be the most optimal cutting scenario, right? I have the air assist, I have the 3 element, and I have the honeycomb bed. This is gonna be the most optimal version of cutting this thing out. So obviously I can lower speed, but I wanna know if I can get away with not lowering the speed. So let's tighten up the air assist here. And let's plug this in. All right. Let's aim this so we're aligned here. Make sure we're getting airflow where our cut's gonna be. And that seems pretty good. All right, so I'm keeping the file the same. I'm just gonna change well, technically, actually, we haven't actually cut these ones through, so I'll redo this one. So let's start this bad boy up. With the air assist, same setting, same everything. We almost cut all the way through with this. Let's see with the air assist. Oh, I'm stopping the job. I shifted my work bed. So I'm gonna go back to 0. I shifted my work bed a bit, so it was actually engraving on the, yeah, I'm off by just a little bit. So just make sure you always re-zero. So I'm re-zeroing there. So laser off. I'm going to zero it all there. And we'll start that again. David says, nice magnetic solution. Shame the connectors could not also be integrated. Yeah, the connectors are literally just, you know, like you just pop them out. Maybe I will make a little connector thing that like you can shove your wires into that keeps all 3 connectors like together, and then you could just, so it's just like plug, 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 and it kind of keeps the 3 wires of the fans, or the 2 of the power and the fan together. But yeah, the plugs are already like just like pulling connectors. So, you know, in terms of speed, there's not much time I could save you by getting all fancy connectors. It would just be a more expensive solution, which is cool. It's definitely cool. Like there's Opt Lasers that does some really cool stuff with their connectors, but you know, because I'm like a one-man laser show, and then there is stuff I want to do for the LaserBeam, but I'm also ready to make something different with the UltraBeam. I kind of have to pick my battles, and choosing the magnetic mount was definitely one of those battles that was something I could do, but without kind of committing too much to it. But yeah, a magnetic solution would be nice, but maybe I'll make like a little clip that will keep all the wires together and a little bit neater for you guys. I'm really curious because this should be like the most optimal setup right now. And if I can get away, I've never been able to cut 1/4 inch at 4 millimeters per second. Guys, it sounds like something so small, but just like in my 2 years of using this laser, I've never cut at that speed for something this, for wood, like a 1/4 inch plywood, or 6 millimeter like wood, or even when I'm doing 3 millimeter, in order to get it out in 3 or 4 passes, I still have to put it around 2 to 3 millimeters, so, or sorry, millimeters per second. So if I'm able to cut this 6 passes with at 4 millimeters per second, 25% faster, then this is definitely my new cutting setup. And you know, cutting just definitely got a lot easier. So I'm very excited. I'm hoping this comes out nice, and then, but if it doesn't, I'll add another pass, or I'll lower the speed. We'll try 3.5 millimeters per second if this doesn't work. I really do hope this works though. Yeah, I got an email saying like, hey, do you guys have any, anytime you guys ask me for a solution that goes above 7 watts, I have to point you guys towards other companies. And of course, my primary goal is to do the CO2 laser because, you know, we have something on the low end. Let's go all the way to the high end. So now, you know, at least we have the 2 extremes. You need something super fast and super powerful, CO2 laser. You need something, you know, not as powerful and you don't mind just slapping it on your long mill, then you have the 7 watt. But after those 2 options are in the market, right, LaserBeam, UltraBeam, I definitely want to start looking at something in the middle, which is going to be like a 4 diode, 20 watt laser. I know a lot of companies are already doing it. The reason why I don't like doing it is because these larger companies, we just can't compete with their pricing in terms of like a 20 watt. But if you guys want it from us, because I know you guys don't buy from us, well, pricing and accessibility is definitely one huge thing that we offer you guys. But as long as we can keep it competitive, maybe we're not going to be the cheapest on the market, but as long as we can be in the range of the lower ends, lower price, high quality, then I don't mind putting something out. It's just, it's all about priorities and timing. right? If I had extra, 5 engineers, I would make all the add-ons I told you, and we'd have a production-ready design for the laser within 3 months. But I don't. So right now we're looking to hire for to push development on our alt mill. There's other CNC projects and products that we want to do to service different markets in the CNC industry. I have my multi-diode ideas and accessories, and I also have the UltraBeam, the CO2 laser. So we're definitely looking for more engineering firepower. That is kind of our number one bottleneck at the moment, and it probably has been for quite a little bit. Yeah, we have our eyes on so many different projects, but we need more manpower in terms of the engineering department in order to get them out in a more time-effective manner. But in the meantime, I can create a plan, I can create a roadmap that works for the laser so that you guys can understand when certain things are going to be coming out, and that's going to be my goal. So for next live stream, my goal is to be able to go over a proper timeline and product roadmap of what the LaserBeam looks like, what the UltraBeam CO2 laser will look like, and what the multi-diode will look like. All right, 6 passes with air assist. Oh, and it doesn't look like we cut through. So it looks like we had an even worse job. So maybe we just weren't as focused. But yeah, so cutting 1/4 inch is just going to be difficult, but we are going to power through. I think I just need to lower the speed. So as excited as I was to be using a higher speed, I think I just need to lower the speed here. And we'll see what 3 millimeters per second will do. And I'll put it right back there. I'm also just going to make sure that I'm refocused. All right, I think I'm all good with the focus. Just make sure everything's zeroed. And we're now at 3 millimeters per second, which is still slower than I usually cut things. So, it's still a win. If you go back and look at all my cut files, they're probably like 2.2, 1.8, 2.5. Yeah, Michael, that's fair enough. That's why we're gonna be looking at like a pro air assist. I'm gonna be designing like, so I'll let you guys know what my idea for the pro air assist. So if you've seen other laser companies, or if you've seen a CO2 laser, like it's a cone that gets super fine, right? It's pinpoint. But because we have the twisting laser focus, and you need the inlet to let the tube of air in, that's a kind of press. You press it in, and then you can put the tube, and then you let go, and then it's like clamped on. The way I'm thinking about it is you focus your laser. So first, we're gonna add a lock nut, so that when you get it focused, Then you start twisting the other ring in order to lock it. Then you take the focus, the Pro Air Assist focus or cover, and you put that over so that you can align the tube outlet of the compressed air uh, in a direction that you can actually access. Then you put the tube in, you run, and yeah, so either I'm thinking a set screw on the side, or like a lock nut that you put in after you focus. So maybe a set, like both. So, okay, focus, okay, lock it, slide this on, set screw so that's not doesn't go anywhere. Then attach your hose, turn on the mini air compressor, and run your file. Now you have a direct flow air assist that 100% adds so much more efficiency to your cutting. Anybody who's used a CO2 laser or used one of these direct flow air assists from a compressor, you know, like it just adds so much more cutting ability. So that's what I have in mind. I just need to design something, send it to a manufacturer, send it to our, get the prototypes and the production tests, and then make sure the QA is all good, and then order a small batch of like 200 to 300. If you guys really like it, we'll do a bigger batch for the next set. Yeah, essentially I'm just gonna do, a jet tip. I'm sorry, I don't know if that's like the more official name, but yeah, a jet tip. I need to design a jet tip that will work for this laser, and so that we can, if you already have a compressor at home, then you could just buy the jet tip and you can plug in your compressor. If you don't have a compressor, then we'll probably sell a mini compressor, not one of those really big ones or one of the shop ones, but like a small one that has like, I think the current rate for like X Tools or Creality lasers, like 30 liters per minute type of mini compressor. It's not too big, it's not too loud, but gives you enough airflow that you get the benefits of having that like jet tip air assist nozzle. So that is what I'm thinking for that. So magnetic mount, a modular honeycomb bed, Pro Air Assist nozzle with a mini air compressor optional, and then a venting kit very similar to the dust shoe that you can run a 4-inch inline fan to and vent things out, or ducting so that you can vent it out. That is phase one. All right, I'm excited to see what is up. Did we get all the way through? Maybe we didn't. Maybe we'll get there with the G2. Maybe, as small of a fine point the 3-element is, the loss of efficiency might not be able to cut as well as the G2. Maybe the G2 is just too powerful, and the G2 can actually overcome. Plus, the G2 is a lot lower, so you can actually get the air assist a lot lower. That probably would have helped if I lowered the air assist, but I'm like being very nitpicky at this moment. I think maybe a G2 might have done better. A lowered air assist might have done better. Obviously, I could run it at like my normal speed, which was like 2.5 to 2.2 millimeters per second. But the whole goal was to see how much more optimal I could make the cutting experience. I'm sure with 3 millimeters, it would have been a lot easier to tell the differences, but I wanted to try something like tough. I always struggle. I always have to do overkill with like running it super low or running super high pass numbers to cut 1/4 inch ply. So I wanted to use that as a test. And technically, this did break through. It just like is not clean, right? So, nope, we did not cut all the way through. So I have a feeling I might be like out of focus a little bit, but hey. We did have the one. This one did cut through. I just had to break the last layer, just sand the corners. But I might continue this next week. Maybe even I'll whip up a quick prototype of the Pro Air Assist, and maybe we can compare this Air Assist to a prototype of the nicer one. Maybe I could just start designing stuff just for use for me, and then I use them on the live stream so that you guys can kind of see the results before they even make it to like production. They make it on the shop, and then I can like thoroughly test it. And once I'm happy with the results, then I can send it out. I'm pretty happy with the honeycomb bed already. It's just nicer. It just feels nicer. You have a reference, you have measurements, you have starting points that you can kind of come back to. It's just much nicer. Easy clamps, all that fun stuff. Better airflow underneath. Yeah, so I'm pretty already happy with that. I'll probably start looking at suppliers and ways I could turn it into like a modular set. And then I will start designing a more pro level air assist with a mini air compressor and start playing with that in the next live stream. So that's going to be it for me. At least we got one cut out, 1/4 inch. So you guys know the deal. Thank you so much for joining me. Whether it's morning, afternoon, evening, or night, I appreciate you spending just a little bit of your time with me. My name is Ikenna for CNC Labs. Michael Levine, thank you so much for joining. David O'Rourke, thank you so much for joining. Nicholas J, thank you so much for joining. Scott, thank you so much. Hit me up about the CO2 and making some tags for the wife. Desmond, thank you so much for joining. Steve B, thank you so much for joining. Dana, thanks for saying hi, even if you weren't in the chat. You are the absolute best. If you were watching and you didn't say anything in the chat, I still appreciate you. And if you're watching this back, because you can always watch this back, guys, always remember that. On our YouTube channel, you go to Live tab, and all of our live streams are saved. This is live stream, LaserBeam Live number 47. Oh my gosh, we are almost at 2 years, okay? And I'm very proud of us. But thank you so much for joining me. That is going to be it for me. Have a good night, and take care. All right.